welcome. We're really excited to have Dave with us, and I'm going to just take a minute to do a little NOFA business. First of all, I wanted to say we have several sponsors who have generously donated to make this conference and our other work possible, and we would appreciate if you support them. And when you do, tell them thank you for supporting NOFA. We would like you to mute yourselves during the presentation, and if you don't do it, and then there's background noise, I might have to do it for you. This session is being recorded. I am in a parking lot, so I'm hoping, because I don't have internet at home fast enough, I'm hoping it doesn't distract from anything. Dave would like questions at the end, and there's also a chat feature that you could write your question in, and then he'll possibly look at it during, but he'll be able to get to it at the end also. So what's on your screen now is a map of the land before there were Western inhabitants, before European colonization. And we just want to say, honor the folks who lived here before us and to get to know who they were. I live on land that was once Nipmuc, and so later you can go to this link and find your own place. And what else do I have here? We're encouraging folks to visit our virtual vendors because they have contributed, and we need to help them as if we were on campus at Hampshire. Support them. Oops, and enter our raffle. We're still doing the teacup raffle, which should be a real hoot doing it. So please support that and enjoy the workshop. So I'm going to stop the share, and I'm going to say, welcome, Dave. And Dave is an amazing guy. 40-some years ago, he was working up with a permaculture institute, and I met him then and got my plans for my composting toilet, which I have used and loved ever since. But he branched out into ecological design with gardens and forestry, and written a great book. So welcome, Dave, and take it from here.
Okay, let me start the screen sharing. Hi, it'd be a nice small group. Hello, Michael. Hello, Jane. Hello, Karen. Thank you, Sharon. Thank you, NOFA, all the people who helped make this happen, switching in the middle of organizing from a live conference to an online conference. I can't imagine, having been a conference organizer. So, wow. So let me see here, screen share. All right. Is that showing? Give me a thumbs up when that has shifted to the new. You've already got that. Okay. Michael, do you see it already yet? Thumbs up when you see it? Okay. Sharon was it was taking 30 seconds for the screen to shift after I hit the button. So, you know, if I start talking and it hasn't shifted yet, just go like that or something, and then you can see me making the hand motion there, right? So we'll have a little bit of communication there. And while I'm screen sharing, I actually can't see the chat. So we'll just hold questions to the end, I hope. But we'll use that as a place to log your questions so we can look through them at the end. Okay, so let me see. I want to acknowledge Mark Kravchuk, whose name is at the bottom left of the screen there. He is the colleague that I've worked for years on putting together a book. We were collaborating on a book together on Coppice Agroforestry. Many of the images in this slideshow come from him, including the one here that he took on a misty morning when he was apprenticing in Britain for, and of course, now I'm blanking on the guy's name in Britain that he apprenticed with, but it'll pop up later. But I want to acknowledge Mark and thank him. He's not able to be with us today, but I just want everyone to know who he is, because he is continuing to work on that book. I have stepped back from working on that book, but he's carrying it from here in his copious free time. And yes, you get the snarky comment, I'm sure. I say resprout silviculture for a 22nd century for a couple of reasons. First of all, as we'll learn, coppice is one form of agroforestry that we're talking about. Some people use that to mean a specific technique of dealing with woody plants, which we'll get into. Other people use it in a more general way. The term that I think is most accurate, which is a term that Mark and I coined, is resprout silviculture. And you'll understand what that's about in a few minutes. And I say resprout silviculture for a 22nd century because, in my opinion, if we don't learn how to do resprout silviculture, we will not have a 22nd century. So, just to be very hopeful here. I don't know what's going on here. Okay. This is a photograph that Mark took when he was on a trip in 2011 throughout southeastern Europe doing a study of Coppice agroforestry over there. This is a mountain range, an east-west mountain range between Greece and Macedonia, or Greece and Bulgaria. I'm not sure which at the moment, but this is the north side of those mountains. He was there in the wintertime. And virtually everything you see in that photograph is a Coppice agroforestry system. Southeastern Europe, the last data we have since, which is not too long after the fall of the Iron Curtain and all that, between 40 and 60% of most forest land in Southeastern Europe that had been under Soviet control was still managed as coppice woodland up to about 20 years ago. And that is because they were still involved in a very intensive subsistence type economy. They were not an export capitalist economy. On this side of the mountains, the north side of the mountains, a lot of that is chestnut. On the south side of the same mountain range is mostly oak because it's drier on the south side and cooler and moisture on the north side. So the habitats were different and the species were different. That is now changed. The fact that it's 40 to 6% coppice in that region is now changing because they're trying to figure out how to transform the coppice systems into what we call high forest with the big diameter trees that are cut and taken to a sawmill and turned into lumber with industrial equipment because they're now part of the export capitalist economy. But this approach to forestry has been going on for a very, very long time. The word coppice comes from the French word couper, which means to cut. Basically, the core idea of all these styles of agroforestry is that you have a tree, you cut it down to a stump of some sort, some level, either down to the ground or something up high or anything in between. After that, you can see these buds that are sprouting here. I don't know if people can see my cursor, but I'm circling these buds coming out. This is alder. There's buds popping out of that alder stump on the right there in the spring following cutting. And then within a short time, it starts to regrow. That's the same year. And then over a bunch of years, it gets to be a tree again, or more than one tree again. That cycle is, so coppice means to cut. It means the act of cutting to manage woody plants this way, but it also describes the material that regrows and the material that you get out of the process of cutting for that purpose. Resprout silviculture, I think of as the more broad term where we're trying to manage plants and woodlands as a system. And the key word there is system, where we're cutting the trees and shrubs or letting them resprout and then harvesting that regrowth on anything between a 1 and a 60-year or more cycle. It depends on what the species are and what the products are that you want, how long that cycle is. And it is a cycle. It doesn't have to be a rigid cycle. It's to be exactly 15 years or exactly 20 years. It depends on site. It depends on what material you're trying to get out of it. It depends on what the species are. you know, how long those cycles are and what kind of range those cycles can be to get what you want out of it. There are a lot of different forms that this can take. The top left image here is a coppice stool, which I was just showing you in the previous slide, where you're cutting it basically down to the ground or to a stump low to the ground, and it resprouts, and then you may select along the way to thin it, and then you harvest it all at once. We have shredding, the bottom left there. Those are 40 to 50 foot tall trees that are trimmed all the way up to the top and then allowed to resprout on a 1 or 2 or 3 year basis, every 1 or 2 or 3 years, to get small diameter material for craft and for fodder for animals. The top right is a pollard stool, a very large pollard that you can climb up into, and that gentleman is using an axe to harvest material, again, for craft or fodder for animals. And the bottom right is called hedging, which some people, you know, is one of the more commonly known things, although people don't really understand hedging. If they do know what hedging, often they don't really understand what it takes, and we'll get into some of that in a little while. There are even other forms, but the core thing here is coppicing. This is a gentleman that Mark was an intern with in Britain, and that is a chestnut, a European chestnut stump or stool, they call them, that was cut the previous spring. This is October, and that is 1 year's growth of a chestnut stool. And that's a good thing, because you have deer damage, you have rabbit damage, and the trees have to outgrow those herbivores to have a chance of surviving. And the reason that they can grow so much is because there's a huge root mass with a lot of stored carbon, stored sugars in the roots that can fund that growth for the first year or two. After that, the plants need to use sunlight in order to keep growing. So you really need to have good sunlight for coppice to succeed, because there's only enough sugar or carbohydrates in the roots for 1 or 2 years growth, depending on the species. Notice also that those stumps or stools are pretty close together, 4, 5, 6 feet apart, and that makes those shoots grow pretty much straight up. If they're farther away from each other, the stools get like a curve to them, which makes the material harder to use for almost anything. Now, this is a photograph that is taken out of a book quoted at the bottom there by Kat Anderson, called Tending the Wild. She was a ethnobotanist and anthropologist working in California. She was a graduate student, and she knew her plants, and she was working in the one of the museums, working with Native American artifacts in the museum, and basketry was one of the stuff baskets were one of the things that she was working with, and the baskets she was looking at and working with, they were identified as to what the species were that the baskets were made of. And she was seeing things that labeled redbud or Cercis occidentalis. And she's like, that doesn't look like any redbud that I know of. Because she understood redbud to look like the image at the top there, that branch at the top. But the branch at the top was not being managed by native peoples. And what she figured out, that led her on her whole quest to figure out what kind of land management practice Native Americans were using in California. And she developed this diagram based on what she learned, where you have at the top left where it says start there, it says an adult shrub. You have adult shrubs that are getting natural disturbances, insects, diseases, lichens, and mosses. They begin to weaken, and if nothing happens to them, they go down to the bottom left there, and they senesce, S-E-N-E-S-C-E. They just get old, and then they start to die. But if they get disturbed, either by lightning or flooding or herbivory or fires or pruning or coppicing, it actually literally rejuvenates them, because their age, their biological age is set back, and they regrow, and they grow new straight shoots that have no insects, no diseases, no lichens and mosses. They have juvenile characteristics in many ways, although they are reproductively not juvenile, because the plant is usually past puberty, shall we say. And so if you can get into that cycle of rejuvenated shrubs, new straight shoots, and then harvesting, and keep that cycle short, and the plant does not senesce by becoming adult and having just getting weakened over time, then those plants can live for very, very long periods. In fact, in Britain, there have been coppice stools or stumps that have been just figured out. They've figured out that they're over 1,000 years old, up to 2,000 years old, continuously coppiced for that long because of this rejuvenation, this biological rejuvenation. And I could explain exactly how that rejuvenation works, but I don't have time today. In researching the book, I found this paper that's quoted in the bottom, the citation is given in the bottom right corner there by Anders Fischer from Denmark, an anthropologist, and he tells this story of how when he was a kid, he was into archaeology, and he had a map on his wall of the area where he lived in coastal Denmark, showing all of the archaeological sites where humans had been identified to live in villages on the coast of Denmark. And he had that on his wall when he was 11 years old, and his parents were having a party one night. And this gentleman who was somewhat drunk had to go to the bathroom, and he went in the wrong door, and he walked into Anders's room, and he saw this map on the wall, and he came out with a red face because he was a fisherman. And he went and found Anders and said, "How do you know all of my best fishing spots?" Just angrily accusing him because they're very secretive about their fishing spots, right? So this made a light bulb go off in Anders' head, and he started learning how to dive. And what he did was start diving as a graduate student off the coast of these archaeological sites. And he found off the coast in the mud at the bottom of the ocean, these fish weirs. Now, these are objects like you see in the bottom left. They are vertical stakes driven into the mud with woven hazel stems. And the longest one they found was 1/4 of a kilometer long, 250 meters long, in waters 4 to 5 meters deep. And he found that they were built several times in the same spot using 6,000 to 7,000 4-meter-long, good quality hazel rods and hundreds of 6-meter-long poles. In order to produce those materials, they needed to have a large organized effort, and all of these rods and all of these woven materials between the upright verticals were very straight, very equal diameter, as you can see in that photograph to the right, and they were so tightly woven together that a diver, when he found one on the floor of the ocean, could not stick his finger between the pieces of hazel that were woven between the uprights. The only way that material could be produced easily in quantity is through coppice management. Basically, what that means is that you'd have to have to do that every year, because what they would do, what he figured out was that what they would do is they'd build this in the late summer into the early fall. And then they would catch eels, would come downriver in the fall that had spawned in the rivers during the summer, and they would then travel along the coast, and these would direct them into baskets. You can see that at the left-hand side of that bottom left image, and they would hold the eels in the ocean as a live protein source for many months during the wintertime. And they could trade them inland. They could, if they kept the skin of the eel moist, they could carry them inland for many, many miles. They could live for up to 2 weeks just with moist leaves around them and stuff. It was a major food source for people in prehistoric or Stone Age Europe. And they found they're at least 6,500 years old, these objects, which means that they were coppicing at large scale in organized groups before agriculture reached Europe. That means that coppicing was really the first form of agriculture. And I've not seen anyone anywhere ever say that. The coppicing was the first form of agriculture, but likely it is true worldwide, because Stone Age tools required wooden handles, and the best way to get wooden handles is to coppice. So why are we interested in this now? Well, the basic thing here is we have to go from a hydrocarbon economy to a carbohydrate economy. If we do not stop relying on hydrocarbons, ancient fossil fuels, we're going to destroy the climate. It may already be too late, I'm sorry to say. But we really need to figure out how to stop trying to be growth tech. And I don't think green tech stability is really realistic given the way we're destroying the planet. Really what we're dealing with are either the regenerative descent scenario, which is where we design our way out of the pickle that we're in, or we're dealing with a lifeboat situation. So, you know, as David Holmgren of permaculture fame says, the real issue of our age is how do we make a graceful and ethical descent from the energy peak? And to do that, we have to go back to a recent carbohydrate economy, away from a fossil hydrocarbon economy. And the only way that I can see how we're going to do that at scale is using Coppice Agroforestry in various forms. There's a lot of different products we can get from these kinds of systems. And Mark invented this added value continuum idea. And you see here's a bunch of different products that you can get out of Coppice materials, from the low value minimal processing side to the high value high processing side. Wood chips, fodder, firewood, faggots and fascines, garden products, ornaments, charcoal, food, medicine, wine, mushrooms, propagation stock, woody cut stems for flowers, fencing, structures, crafts, basket, furniture, and art. And let's talk quickly about some of those possibilities. This is an image from the work of a man called Jean Pan in Mediterranean France. This is a huge pile of wood chips that he was doing fire protection in his dry Mediterranean environment by thinning and pruning in his landscape. And he's started making wood chips. And one day he realized that his wood chip pile was super hot inside. And so inside that pile of wood chips right there is a biogas digester. And around that biogas digester is a coil of pipe. And the coil of pipe is a passive water heater, because the water can go, the cool water comes in the bottom and it just gets heated up, and the warm water goes out the top, and you can see that pipe going off the left. The biogas digester is filled with water and wood chips, and the biogas is being stored in those inner tubes you see to the right. So he's heating his house, he's heating his hot water, and he's cooking and lighting his house with a pile of wood chips. I won't go into the details, but that is entirely possible for us to do. Mushroom logs. A lot of people are getting into growing mushrooms, gourmet decomposers. A lot of the species of mushrooms that people want to eat will grow on coppiceable wood, like poplar, oak, willow, and other species, maples, and so on. And for some of those, you want 6 to 8 inch diameter stump or logs, and that can take maybe 10 or 15 years, depending on the species and the situation, to grow. But we can totally have a continuous supply of mushroom logs and therefore mushrooms in coming out of a Coppice style system. Fodder for animals. Now, this is a big one, and a lot of people are really interested in it, so I'm going to spend a little more time on this. These are goats eating black locust. I found a study about black locust where they were pollarding black locust, and I'll talk about pollarding in a little more in a minute. But this is a diagram from this paper that is quoted at the bottom, the site cited at the bottom there. They're looking at the black is the foliar biomass, the light gray is the shoot biomass, the dark gray is the total biomass on a monthly basis throughout the growing season. You'll see that the foliar biomass, the A, is highest in August, and then starts to decline because it turns into more solid shoot biomass over time. So the highest, the peak of biomass that's edible by animals is in August. And they were getting about 4,700 pounds per acre of black locust. This is 32-inch high cuts, and they're planted about 32-inch on center, 6,000 trees per acre, cut at about 3 feet high, 3.3 feet high. So in August, the crude protein content is about 20%. It starts out at the beginning of the year at 24%, which is much higher than alfalfa. And by October, it's down at about 17%, which is just a little lower than most alfalfa. But it's still about 20% crude protein in August when they've got the highest foliar biomass, and that's higher than alfalfa typically is. So that's really great, not as a sole source. You don't want too much protein for livestock feed, but it's really a critical factor in fodder for animals to have sufficient protein. You got to make sure it's digestible, though. The dry matter digestibility for cattle ranges from 53% in the end of the season to 66% at the beginning of the season. And it's about 56% in August when you get that highest crude protein content. That is comparable, if not better, than alfalfa for digestibility. There are many species of woodies that can be used for this. I have a list I'll show you in the back. I thought that was next, but there's handouts, by the way, that I can email to you all. If you email me, I'll give you the email address at the end. And you email me, I'll send out a bunch of handouts on all this stuff. So that's some stuff on fodder for animals. Then we have firewood, of course. You know, hickory. This is a table of the density and BTUs per cord of a range of different woody species. Hickory will coppice, Osage orange coppices, black locust coppices, white oak, red oak, white ash, sugar maple, elm, beech, birch, black walnut, sycamore. All those species will coppice. Silver maple coppices. Most of those species will coppice. And you can see that you can get pretty high density and pretty high BTUs per cord, and with different qualities for how many coals they'll make for blacksmithing or whatever, or just having a long-lasting heat source overnight. So, you know, I've been developing a database of all this kind of information with a bunch of different species for the book that Mark and I have been working on, and that'll become available at some point. Charcoal is a critical piece of this. In fact, without Coppice Agroforestry, we would never have had an industrial revolution, because charcoal made from coppice chestnut was critical to developing the ability to smelt, well, first bronze and then later on iron and steel. And without that Coppice Agroforestry, we would have not been able to figure out how to make the tools that would have allowed us to begin exploiting coal as a source of energy to make metal, and therefore we would not have had an industrial revolution that got us to where we are, for better or worse. This charcoal is one of the main products that is made with that pays a wage for people doing coppice management in Britain as of now. Woody cut flowers are a whole nother piece. It's a whole 800-page book. I'll hold it up for you right here, right now. Huge, massive book on woody cut flowers for ornamentals. There's a fairly, small but robust economy of people who are growing woody cut flowers for sale to the flower industry. This is red twig dogwood, which is one of the easy ones. There's many other species that have great ornamental qualities, and it's actually, you can make a decent amount of money if you're near the right market for that. But they're perennial. You don't have to keep plowing the ground, tilling the soil, and all that. It's a perennial, and you have better wildlife habitat, more stable water regimes, all kinds of benefits coming out of that. Fencing, what you see in front of you here, those are called hurdles. You can see how they're wired to a post. There are even hurdles that are more like the fencing in the back, that are woven hurdles, that are a denser hurdle. Those hurdles are essentially the electric portable fencing of the past. And that was made by coppice material. Hazel, European hazel is the best fencing material, the best weaving material that we know of, because it's the only species that we know of. The American hazels may be similar, where you can bend it 180 degrees without breaking it. So if you twist the hazel when you bend it, it will not snap. Whereas any other species, when you bend it 180 degrees, it'll snap. So when you're weaving a hurdle like the one in the back, but you come to the end of that one section you want to weave, you can twist the hazel back on itself and fold it back in, and it'll stay put in without breaking. Basketry is a huge, huge piece. In fact, I saw a guy write a whole article about basketry, and willows are one of the better basketry set of genera. These are high-end baskets made by a woman who makes a lot of money making these baskets out in California. There's different cultivars that have different bark colors, which is why you see the colors there. They're not dyed. Those are the natural colors of the bark of different cultivars. You know, you can even make caskets out of these. And there's in fact, I was looking at the news this morning. I don't know if you heard, but John Hume, who is a Nobel Prize winner for helping create peace in Northern Ireland, his funeral was yesterday, and they carried him in to his funeral in a basket just like this. So people are using these, and there are people in the US now who are making willow caskets for that purpose. So you can make buildings out of coppice material, and it turns out that a 6-inch diameter round timber is stronger than a 4x4 piece of lumber. I mean, a 6x6 piece of lumber, because the fibers are intact all the way up and down the length of the piece of wood. Whereas when you saw that lumber, you cut those and it weakens the wood. So round timber construction is stronger. It's less work in the preparation, but it's harder to build with. And also shingles. You can make shingles for the roof out of coppice material. And then these are chairs that Mark himself made out of coppice material. That's black ash caning, and then I'm not sure what the uprights and horizontals are made of, but it could be ash, it could be other species. But those chairs are, you know, worth a fair amount of money. They take a fair amount of work, but it's good stuff. All right, so there's a lot of different products you can get out of this, and you know, I just want to say part of the challenge of this whole thing, and part of the challenge of agriculture in our time, is that we live in a world where we have cheap fossil fuels, so that the price of energy is low and the price of labor is high. All these technologies that I'm talking about here are optimized when the price of energy is high and labor is low. And we don't live in that culture right now. But when we run out of fossil fuels, then that will switch. So we have to figure out how to use and develop these technologies during the time when energy is cheap and labor is expensive, so that we'll have them available when that switches, and it will switch, guaranteed. I think it's guaranteed. So I want to talk a bit about how coppicing actually happens. Let me see what I'm doing on time here. It's been about half an hour. Good. There's then the biology of resprouting is quite complicated, and there's very few people who've written about it, and it's not written about very well in any one place. So there's a lot of terminology problems, and which is classic in botany anyway. It's even more so when you start talking about the physiology of buds and plants. So this is my diagram that I created to summarize the different kinds of buds that I found in the literature. And I'm not going to go into all the detail. I don't want to try and explain it to you. I just want to just put this in front of you. This will be in the handouts. And there's 3 kinds of buds that I want to talk about. There's what we call the original recipe buds. These are buds that allow the plant to express its genetically predisposed growth habit. Is it opposite branching or alternate branching, you know, etc. Then there's buds that are built into the plant that anticipate disturbance, getting browsed or having a fire or whatever, and allow the plant to regrow after that disturbance occurs. And that prevents the plant from dying and allows it to regrow rapidly in the case of disturbance. And then we have these de novo, which means new, or adventitious buds. And the adventitious buds form anew from undifferentiated cells after a disturbance, if there are no buds available that were previously, that are preventative or preventitious buds that were waiting for a disturbance to occur. So I want to just talk briefly about these 3 kinds of buds and give you examples, because the kinds of buds that the plants have, and different plants have different kinds of these buds, the different buds the plants have will affect how you manage the species. And there's very little in the literature about which species have which kinds of buds, and therefore how you would manage them for coppice. So you need to have some sense of this so you can understand by looking at a plant and seeing how it responds to your pruning interactions, so you can figure out how to manage it based on the biology. So that's why I'm giving you this basic, nutshell thing here. So the original recipe buds are, again, those buds that help you to express Colonel Sanders. It's like, that's really, maybe that's racist, I don't know. That's where the term came from. We don't want to get sued by KFC, but in any case, the plant has a pattern in which it wants to grow, and you can see here. This is European filbert. It has alternate bearing, alternate leaf pattern, and the branches will also be alternating branches, because those axillary buds are what will grow new shoots. Each bud is the beginning of a shoot. The terminal bud is at the very end of the existing axis of growth, and that will continue the same growth of that same axis of growth the following year after it goes dormant for a period. So that Hello? Thumbs up, can you hear me?
We can hear you, we can't see you.
Okay. I don't know why things are flickering here.
Now we can see you.
Okay. So you can all hear me? Thumbs up if you can hear me. Okay. And you can see the screen, right? Okay, good. So I'm not sure where I dropped out, but the stem you see, vertical stem you see there, terminated at the terminal bud for the growth for the year, and that terminal bud will continue that shoot, the growth of that shoot the following year. The axillary buds, which grow in the axils of the leaves, where the leaves attach to that stem, they will create a new shoot off the existing shoot when they start growing, whenever that is. They may not start growing. Some axillary buds begin to grow the same year they form, some grow the following year, some grow 2 years later, some never grow. So that's part of the original recipe pattern of growth. Oops. All right, then we have, so those were the original recipe buds. Then we have the disturbance anticipation or preventitious buds, and that is what we call an accessory bud, which is a little tiny bud down here, which you can see labeled there. So we have here the stem of this red oak. Then we have the leaf petiole on the left, and in between in the axil is the primary axillary bud, and in the axil of the primary axillary bud is an accessory bud, and there's another one opposite that. So there's a pair of accessory buds in the axil of the buds, and those are more likely to become dormant buds later on, and I'll explain what that means in a moment. So then I also show on that diagram where the scales of the bud are. You can see those are little modified leaves that protect the growing point inside of the bud. And you can also have buds at the axils of the bud scales inside the bud. So it's a fractal structure, and that fractal structure is basically a tree of red oak in miniature packed into that tiny little bud. Now what happens sometimes is if the axillary or accessory bud does not grow into a new shoot, that when the next year's growth of the stem occurs, the stem grows in diameter. That's where the rings come in, the rings of growth. The stem grows in diameter, and the bud gets swallowed up by that stem growth in the diameter of the growth, and the bud remains dormant below that bark, and the bud will follow the bark as the stem gets wider and wider year after year. The stem will follow that. So this is a fence post, and you can see the rings of growth in that fence post. This is a fence post that was riven out of a round piece of wood. If you looked at the top of this fence post, it would look like a slice of pizza. So the right-hand side is the outside edge that's rounded, and the left-hand side is the corner of the pizza that you'd bite first, right? So you see here in that dormant bud trace, see that structure across there where the bud that was dormant was growing along with the rings, but never grew into a shoot. That's called a bud trace or a stele. All right, so that dormant bud is sitting there waiting for the tree to get eaten by a deer, or get hammered by a hurricane, or have a fire cause damage, and that would cause that bud that was at where the tip of the arrow is to start growing into a new shoot. Those buds are what a lot of coppicing is based on. And so these dormant buds, they can they often will grow themselves. So the dormant bud is actually moving.
I didn't learn the hard way. I'll learn the hard way.
Right. Somebody needs to be muted. Raruda, could you mute yourself? Thank you. Those dormant buds themselves grow. So on the left-hand side there, you see a 1-year-old axillary bud, and then you have on the right a 15-year-old dormant bud of the same species, sugar maple, and that dormant bud has put on a ring of growth of bud scales every year for 15 years, and has at the axils of those bud scales, there are more buds or germs of growth at each of those bud scales. So those buds are growing out every year. Some of them die off. There's like a population of buds in a given tree, and there's some death of those buds every year as the tree grows in diameter. If they don't activate, some die. Some of them keep growing, but sometimes, as in this shortleaf pine, which is one of the few coniferous species, the pines and hemlocks and spruces, those are conifers. Most of those will not resprout when you cut them, but shortleaf pine will. And you can see here bud traces in the shortleaf pine, and you can see how this bud trace with the arrow toward it, how one bud trace then multiplied and 2 bud traces continued on it, because the tree experienced something that caused that bud to split, and the buds that were inside the one bud started growing separately as new buds. And most of those buds ended up dying out, except for the one on the right, which made it to the bark, you know, out here and started regrowing. That is a bud trace that started growing out here in the upper right corner, right? So that's a new shoot that is formed from the bud that started way back here in the very first ring of growth in the center of that tree. That bud has grown for all those years. I should probably count those rings, but that's, you know, 20, 30, 40 years of growth rings. That bud stayed alive. All the rest that you see there died, but that one bud survived to grow into a shoot that allowed, if that tree got cut down, that would turn into a whole new tree eventually. All right, so that's what I call a multipliable bud, where the bud, a disturbance can cause more than one bud to activate and restart and start growing. Now, I don't know if you know this, but when you take a black cherry tree and you cut it down, a black cat will pop out of the stump. That's not coppicing. That's some other form of magic I don't understand. But there are also buds that form at what the root collar is called, the root collar, or it's called the basal collar of the tree. That is the place where the stem wood meets the root wood. You've got a change in the structure of the physiology of the tree at that point, but often you have a ring of buds that will form at that place where the stem wood meets the root wood. And all these shoots you see here from this black cherry are coming from that root collar. These are the best kind of coppice shoots to have. So the root collar is at what's called the cotyledonary node. This is a sugar maple seedling. You can see the seed husk and the wing there. It's about to fall off, and the new leaves are all folded up and they're emerging. And that arrow is pointing to the place where those seed leaves or cotyledons are attached to the stem, and that is where the stem wood meets the root wood, because everything below that point is root wood. That's where the root collar would form on this tree, is actually above ground. Some species, like black cherry, that cotyledonary node is actually below ground. And when that is true, if you cut this black cherry tree, those shoots come out of the basal or root collar area. Each one of those shoots can start making its own roots because they're below ground. And what that means is that if that stump rots from the middle of that stump, where the wood is actually dead in the middle of a tree, it's not actually living. So that's where the trees are often rotting, is from the middle going to the edges. If that stump rots from the middle, those trees will still be able to survive, because they have those shoots will still be able to survive because they have their own root system. What that means is that if you have root collar sprouts, that you can have a long coppice cycle, 40, 50 years, because each shoot is going to make its own roots. Then you can cut that and it'll shoot from the ground again and make its own roots. So you can have a long rotation on a root collar sprout. Whereas if you're cutting like that early photograph I had of the alder, where it was coming out of the side of the stump, if that stump rots, that whole thing could fall apart and the shoots could die because they are not below ground. But alders don't have root collar sprouts typically. So this is why we have to understand the biology of the sprouting, so we understand how to manage. Because if the plant will have root collar sprouts, you want to cut it as low to the ground as you can to force it to sprout from below ground, so you can have that long rotation and not have rot of the stump destroy your coppice sustainability. All right, then we have root suckers, which are shoots, stem buds that are lying dormant in the roots or in a rhizome, in this case, of a tree. This is black locust. So black locust shoots out of the roots and makes a whole stand. And so that's a stem bud in a root that is popping out and making a whole new tree. So sometimes you might cut a tree down and it starts popping up away from where the stump was that you cut down. Poplars do that. Black locust does that. Sweet gum does that. There's a lot of different species that'll do that. And that's a whole different issue in management and a whole different kind of system that will arise out of that form of biology. All right, and then we have the de novo or adventitious buds. And they're actually not buds, because you have this ring of living cambium that is between the bark and the stem and the wood of the tree. Those are the living cells that divide and spread outward and inward to form the bark and form the stem of the plant. And that cambium is undifferentiated cells that divide in that way, and then they differentiate into the different kinds of cells to make the plant. Those undifferentiated cells, if you cut, this is a beech, American beech, if you cut that beech tree and it has no buds, they don't typically have dormant buds that sprout that well. They have some, but they can form new shoots out of undifferentiated cells at the cambium. This brown little lip you see running around the edge of that wound, that's all callus tissue, and those new shoots are growing from undifferentiated cells out of that callus. And what that means is those new shoots are not very well connected to the trunk of the tree. And so they're easily broken off, and they're not going to live very long unless the callus and the stem keep growing over each other really well. So these adventitious buds or de novo buds or shoots, they are typically a short rotation material, 1, 2, 3 years. and then you cut it again, and then you get more adventitious growth. So these different kinds of buds are going to have different implications for management. So this gets us to this whole question of the different bud types and the different severities of disturbance you're going to subject a woody plant to. So when you think about browsing by an herbivore like deer or moose, if they're eating only the fresh twigs or maybe the fresh twigs or the leaves of the current year's growth, the axillary buds that grew that year will be able to grow the next year and respond to that. So if you were harvesting fodder by just trimming off the little twigs and feeding that to your animals, if the plant could only regrow from axillary buds, it would survive that. But the other kinds of buds, some of which I haven't talked about, the shoot germs, the meristematic points, the accessory buds, and the adventitious buds, those could all also respond to that. When you start cutting into the previous year's growth, or even the 3-year-old growth, then the axillary buds will not be available to respond to that because the axillary buds are usually not there that long. So the accessory buds are your primary dormant buds that are going to be there, or maybe some shoot germs or meristematic points. Again, I didn't talk about those yet, or the adventitious buds that can respond to that intensity or severity of disturbance. And then if you cut back to the main stem, again, accessory buds, but there's going to be fewer of them because the population of accessory buds, of dormant buds, dies out as the tree grows in diameter or age. And so there's less ability for many species. You know, there's even some data we've been able to find that the amount of resprout will drop dramatically after 6 inches or 8 inches or 11 inches, depending on the species. It varies how much sprouting you get at different diameters of stem. So you're dealing again with accessory buds, but the number of species that can handle that intensity or that severity of disturbance, you get fewer and fewer that can respond to that. And if you cut all the way to the ground, the accessory buds might still be a few there. You're not going to have any axillary buds. You might have other stuff, but you're dealing more with those root collar. I didn't talk about lignotubers or rhizomes or root shoots, but the suckers, you know, those deeper things, those can respond to that level of severity. And so we have to begin getting the data on which kinds of trees have which kinds of buds and therefore how they can be managed. For North American species, we don't have that data, unfortunately. And we have lost the knowledge the Native Americans had because we wiped them out before we cared to ask. But the disturbance of the severity of disturbance and the kinds of biology of the plants will lead directly to the kind of systems that you can have for management. Here are the different kind of systems that we can talk about. We've got high forest, which is what most of us are used to in the northeastern US, where you have a mature tree, you're cutting it down and you're either letting seedlings or planted plants or root sprouts to replace a big diameter tree you're cutting for lumber and you're taking it to a sawmill and milling it up. A coppice only system is called a copse. Then you can have coppice with standard trees where you have a scattering of standard trees for nut production or timber production with coppice underneath. And then you can have wood pasture, the bottom image there, where you have widely scattered trees and you're pollarding, you're cutting up high above the height of browsing or grazing animals so they can't reach that material, and you're growing fodder or other materials above out of the reach of those animals. And then you have the shredding and hedging that I talked about before. And these different systems relate to the physiology that I've talked about. So here's what a copse looks like. This is a copse of alder that was planted probably about 150 to 200 years ago in Britain, the picture that Mark took. It's the monoculture of trees, but it has a diverse understory. We can't see that in the time of year this picture was taken, but that's what it looks like. Dense spacing. You want, again, those upright shoots to grow. There's a little bit of self-thinning that goes on over the years. You can see some shoots grow and become big diameter. Other ones die out over time. And that, you know, typically in the early medieval era, copses like this were a diverse mix of species. But once the commons were destroyed, and peasants were not being living in a subsistence fashion on the landscape, and they were trying to use coppice for capitalist production of single-use products. Then they started growing monocultures back in the medieval era. For this kind of system, the optimal spacing depends on the length of the rotation. You're mostly in the 6 to 8 foot range. The longer the rotation, the wider the spacing. You can put short rotation stuff like basket willow at the 1 foot centers, longer rotations 6 to 8 feet up to 11 feet. And when you're organizing that in the landscape, you usually grow stands called cants. So yes, we can't. That's a nice little, that's an Obama era joke. But a cant is a stand of even-aged coppice that you cut all at once. So you're going to identify your stands based on similar site characteristics, species, age, slopes, soils, etc. You're going to use different access patterns. There are pathways between all these different, you can see these cants in that landscape there. This is again in Britain. You want to have good access so you can manage it well, but those access patterns also define the areas that are going to get clear cut at one time. Those clear cuts should be at least a 1/4 acre, which is about 100 feet by 100 feet, so that you have good light for every stool in there, and you want to minimize the edges to simplify browse protection. What that means is that you're going to cut each one of those colors that are showing up in a given year, and you're going to have, let's say you're doing I think it's a 10-year rotation, 2, 4, 6, 8, 10. That's an 11-year rotation. If you're doing all those as one system, you'd have an 11-year rotation. You'd cut one of those a year, and then every one of those cants would be a different age. And that's, you get your diversity in the landscape by having different aged cants across the landscape. So it's between habitat diversity, not within habitat diversity. And then you're getting a consistent yield per year because every one of those cants is similar in size and you're getting a similar yield out of it. But you're trying to, you can imagine that the purple one at the bottom here that's very oblong, you're going to have a lot more edge to that. So it's going to be harder to protect that from deer and so on, as opposed to the pink one on the far right. That one is much more compact and the edge area is much less. So it's easier to protect it from browse. So those are the cants, and that's how you design a coppice system with an even amount of cutting every year. And then if you're doing coppice with standards, you want to have, again, nut or timber trees in the overstory like oak, hickory, or walnut. And then you want to have your coppice underneath. It has to be on a short or medium rotation for fiber or other products, because you don't want the canopies of the coppice to interfere and compete with the canopy of the full-size trees, because that causes problems in both crops. And then underneath the coppice, you can have perennial vegetables, medicinal herbs, fertility plants, mushrooms, livestock like poultry or rabbits in that herbaceous layering. So you can get a lot of diverse products out of those kinds of systems. This is what a coppice with standard system looks like in the winter, just after you harvest the coppice, and then the summer following when you see the coppice regrowing underneath. Notice how the branches of the trees, the mature trees, are going up and down like this as they grow, because the coppice, as it grows, the tree branch is growing up to avoid competition with the coppice material. And then when the coppice is cut, it'll grow down to avoid self-shading from the branches above and get more space. So that's how you get those bizarre shapes in those branches, is by that management. And notice that it's only the lower branches that have that wave to it, and the upper branches are a little more consistent. All right, pollarding is similar to coppice, except you're doing it up at a higher elevation in the tree. It's a training system. I do not know what species this is. I do not remember. I'm not sure I ever knew. But those big lumps at the end of each branch, those are called knobs or heads. And those are heads of callus where the first cut was made. Can you all see my cursor here? Thumbs up if you can see my cursor on the right-hand side of the screen. Okay, so this place where the normal bark meets that head, that's where the first cut was made to start forming this pollard head. This is many years of cutting at the very end of that head in order to grow the callus. And I won't get into the details here, but look in the bottom right. This is where we're getting into branch epicormic. You're cutting into the branch material and letting that branch regrow, typically from adventitious, the callus, the new shoots from callus, from undifferentiated cells, or from dormant buds that grow at the accessory buds at the axils of the leaves or the buds. Notice there at the bottom of the picture, if you go to coppiceagroforestry.com, which is the website that Mark and I developed for the book that he's writing now, there's a blog post that I made on April 28th of 2017 that gives you the details of the biology that we figured out and how you actually begin to form coppice heads, the pollard heads, I mean, by management. And it's good to understand more of plant biology and how you prevent decay of woody material, and there's a lot of different stuff involved in that, but that gives you a lot more detail than I can go into there. And again, this is being recorded. I believe the handouts have a link, have the reference to that. So if you email me for the handouts, I'll give you the email address at the end again. You can get that information if you didn't write it down. So here are very old pollards in a pasture situation where there's sheep grazing underneath. These are probably have not been cut in far too long. They should not be as big diameter shoots on the top of those stumps, but look at how big those stumps are. This is a book called Michael Maschatschek called Laubgeschichten, which means leaf stories. It's written in German, but he calls this cultivating the meadow in the air when you manage pollards for fodder. And they use that fodder as a drought or winter fodder source for their livestock. And it was a critical piece, particularly in Northern Europe, northern climates, but it also can be critical in hot climates because of drought, and also because the partial shade, again, notice, as I said, these trees have been let go for far too long. So there should be more sun on that pasture than there is currently, because these were not cut on every third year, maybe every 5 years they should be cut. These are probably 10 or 15 or longer, these shoots, or older. And so there's a lot more shade here than there should be. But even that partial shade of a 3-year pollard rotation is going to cause a lot less heat stress on the grass and a lot less heat stress on the animals, and you can get higher production of pasture in partial shade than in full sun. Actually, if you have the right grasses and the right density of trees, you get higher grass production than full sun because of that reduced stress. That's part of the value of silvopasture. And you can make blocks of pollard for fodder also. This is in Norway, and these are pollard birches. They're just kind of tucked over to the edge of a pasture, so they can all be harvested at once fairly easily, rather than climbing one tree and then coming down and climbing. You can climb from one tree to another and harvest it all at once, and that's, you can have a block of pollards from fodder as well. And then I designed for a client once who is an herb grower, 12-foot wide alleys planted with pollard trees, mostly alder, for fodder for her goats. And if you do 3-foot wide rows, 3-foot wide tracks, 3-foot wide row, 3-foot wide track, you can still run a tractor down there. You can have your herbs growing in the shade, shade tolerant herbs growing in the shade, and then you can have, if you harvest properly, you figure out the height of your trailer, so you can have easy access to harvest your pollards. Just drop it into your tractor, and then you can go dry it and store it in your barn. Here's that list I mentioned. So all these species from Central Europe have relatives in North America that are probably edible. This list will be in the handouts that you can get from me. Again, I'll give you that reference later to email me for that handout. These are ones that there's a woman in Shauna Hansen who's been working with this, with her animals up in Belfast, Maine. She also every year will run, the last several years, she has run a summer course on coppice and pollard management. And she's probably one of the people who's doing the most development that I know of. So I recommend finding her, Three Streams Farm in Belfast, Maine. I'm sure you can find her if you Google her. And she's getting a lot of good data. There's also on Facebook a whole group called Tree Hay on Facebook, and there a lot of people doing really good information sharing there on Facebook in the Tree Hay group. There's also a coppice group on Facebook that's doing a lot of good information sharing that I highly recommend. And again, this list will be in the handouts. You know, I mentioned this earlier, but again, shredding is in this, you know, more intensive, more severe disturbance regime where you're trimming up all the young branches. You're cutting that every year or every second year. I imagine it's a lot trickier. You got to go up there on a ladder. I'm not sure I'd want to be doing that and risking my life and limb to go harvest that material. But this photograph was taken in Greece or Macedonia when Mark was over there in 2011, and it's fairly widespread in those climates. Those are probably poplars. And then hedging is, you know, is a massively important practice in medieval Britain and prior to that. And it's basically, you're using hawthorn because it's thorny, and it can take, as on the bottom right there, you see the tool they're using to cut about 2/3 the way through a hazel tree. You lean it over, so it's almost horizontal. You put a hazel stake vertical to hold those leaned over stems together, and those stems then make a mass of very, very thorny material that animals can't get through. And then those stems will resprout vertical. And over time, the horizontal ones die out, the vertical ones grow up, and every 15 years ago, you got to go back in and cut it and do the same thing over again. And then you weave the top post together with with those hazel, woven hazel to hold it all together. And you get a very, very impenetrable fence except by rabbits and voles and mice and stuff and hedgehogs. And you get diverse herbaceous stuff growing in those hedgerows. You get very healthy habitats there. It's a very high quality habitat, but it's a lot of labor every 15 years. Okay, and then you know, there's basically two approaches to starting a copse. You can plant into an open field, or you can try and develop an existing woodland into a copse. They both have their advantages and disadvantages. You know, you're starting with an existing woodland. You don't get to choose the spacing. You don't get to choose the species very easily. With an open field, you do get to choose the spacing, the species, but you're dealing with grass competition, and you might have meadow vole damage that you wouldn't have in the woodland. It can take a while to get established. It takes a lot more money.